Filling the solar system would take about 2 times 10 to the 39th liters of soup. If the soup is tomato, that works to about 10 to the 42nd calories worth, more energy than the sun has put out over its entire lifetime. The soup would be so heavy that nothing would be able to escape its enormous gravitational pull. It would be a black hole. The event horizon of the black hole, the region where the pull is too strong for light to escape, would extend to the orbit of Uranus. Pluto would be outside the event horizon at first, but that doesn't mean it would escape. It would just have a chance to broadcast out a radio message before being vacuumed up. What would the soup look like from inside? You wouldn't want to stand on the surface of the Earth. Even if we assume the soup is rotating in sync with the planets in the solar system, with little whirlpools surrounding each planet so the soup is stationary where it touches their surfaces, the pressure due to the Earth's gravity would crush anyone on the planet within seconds. Earth's gravity may not be as strong as a black hole's, but it's more than enough to pull an ocean of soup down hard enough to squish you. After all, the pressure of our regular water oceans under Earth's gravity can do that, and Amelia's soup is a lot deeper than the ocean. If you were floating between the planets, away from Earth's gravity, you'd actually be okay for a little while, which is kind of weird. Even if the soup didn't kill you, you'd still be inside a black hole. Shouldn't you die instantly from something? Strangely enough, no. Normally, when you get close to a black hole, tidal forces tear you apart. But tidal forces are weaker for larger black holes, and the Jupiter soup black hole would be about 1/500th the mass of the Milky Way. That's a monster, even by astronomical standards. It would be comparable in size to the largest known black holes. Amelia's supermassive black hole would be large enough that the different parts of your body would experience about the same pull, so you wouldn't be able to feel any tidal forces. Even though you wouldn't be able to feel the soup's gravitational pull, it would still accelerate you, and you would immediately begin to plunge toward the center. After a second had passed, you'd have fallen 20 kilometers, and you'd be traveling at 40 kilometers per second, faster than most spacecraft. But since the soup would be falling along with you, you'd feel like nothing was wrong. As the soup collapsed inward toward the center of the solar system, its molecules would be squeezed closer together and the pressure would rise. It would take a few minutes for this pressure to build up to levels that would crush you. If you were in some kind of soup bathyscaphe, the pressure vessels that people use to visit deep ocean trenches, you could conceivably last for 10 to 15 minutes. There would be nothing you could do to escape the soup. Everything inside it would flow inward toward the singularity. In the regular universe, we're all dragged forward through time with no way to stop or back up. Inside a black hole's event horizon, in a sense, time stops flowing forward and starts flowing inward. All timelines converge toward the center. From the point of view of an unlucky observer inside our black hole, it would take about half an hour for the soup and everything in it to fall to the center. After that, our definition of time and our understanding of physics in general breaks down. Outside the soup, time would continue passing and problems would keep happening. The black hole of soup would start slurping up the rest of the solar system, starting with Pluto almost immediately and the Kuiper Belt shortly thereafter. Over the course of the next few thousand years, the black hole would cut a large swath through the Milky Way, gobbling up stars and scattering more in all directions. This leaves us with one more question. What kind of soup is this anyway? If Amelia fills the solar system with broth and there are planets floating in it, is it planet soup? If there are already noodles in the soup, does it become planet and noodle soup, or are the planets more like croutons? If you make a noodle soup, then someone sprinkles some rocks and dirt in it. Is it really noodle and dirt soup, or is it just noodle soup that got dirty? Does the presence of the sun Make this star soup.
To keep listening to this audiobook, I've left you a link in the description so you can do it, at no cost thanks to Audible's 30-day free trial.